before we get into like actual partial fraction decomposition, I want to talk really quick about what is a proper versus an improper fraction. Fractions. What would be an example of if I said what's a proper fraction? What would you think an answer would be? 3/4, 1/2. I heard a lot of different answers. All of the ones I heard were correct. I didn't hear anyone say one with x's though. What if I had like 1 over x? Would you think that's a proper fraction? Okay. What about an improper fraction? What would an improper fraction? 7/3. What else? 9/2. I like it. What if I had like x to the 3rd over x?
No.
That's not proper, right? I could simplify that, right? Same thing like 8/4. We could simplify 8/4, right? So being able to identify whether a fraction is proper or improper is the first step in solving these partial fraction decomposition problems, okay? This partial fraction decomposition will only show up in this unit in pre-calc, but it will show up again in calculus if you're planning to take calculus, okay? Being able to split these things up allows us to integrate things in calculus a lot easier. So that's why we show it to you here. Other thing I want to say is basically we're going to take factors like, we're going to have like, let's say 1 over x plus 4 plus, I have a fraction, x squared plus 3 with, let's say, a 4x on top, okay? We're taking something that looks like this, okay? If we wrote this as one fraction, I would have to get a common denominator, so I would have to multiply each side, right? This would be times x squared plus 3. This one would be x plus 4. So if we wanted to write this as one fraction, I would have to have a common denominator, right? We are going to be given problems that look like this, okay? They are one fraction, and we are going to work backwards. We are going to split them into their separate fractions with different denominators, okay? So that's like the main idea, okay? Now the steps to get there are a little messy, but we can do it. All right. So here's kind of the steps for each linear and for quadratic forms. I'm just going to kind of jump into an example because otherwise these things are not going to mean anything to you, okay? So for example, we got this whole fraction, 2x to the 4th minus 8x squared plus 5x minus 2 over x to the 3rd minus 4x, okay? So the first thing that we need to check is this a proper fraction? Is the numerator smaller than the denominator? No. Okay, we look at the highest x value. If it is not proper, okay, then we need to do long division, okay? Okay, if it was proper, we could start our partial fraction decomposition. Okay, but for this one, it is not. So we need to go ahead and use long division in order to simplify this polynomial. Okay, so that means I'm going to have my x cubed minus 4x on the outside and my 2x to the 4th. Let's put a place value in there for that x cubed. So let's just put 0x cubed plus minus 8x squared plus 5x minus 2. So this is our step 1. Okay, the first 4 questions on your homework are, is the fraction proper, yes or no? And if it is not proper, you have to do the long division, okay? So we're going to ask ourselves, what times x to the third power gives me 2x to the fourth power? 2x. So I'm going to put 2x up here. And now with that 2x, what do? Multiply. So when I multiply, I get 2x to the fourth. And then I line that up, and I get negative 8x squared. So I'm going to line that up with my 8x squared. So I don't have any x cubes there. That's okay. Okay. Then I'm subtracting this whole quantity. Okay. I like to change my signs, so I'm going to change all of these signs here. So now I'm actually adding. When I add, what happens to my terms there? They cancel out. So this goes away, this goes away. I'm left with just 5x minus 2. Now, is there anything I can multiply x cubed by to give me 5x? No. Okay, so we have done the long division. Okay, we did this last unit as well. So we have divided, and our answer right now is 2x plus my remainder, which is that 5x minus 2, but this remainder goes over what? What's my denominator there? Yeah, this thing, right? This denominator from our original fraction. So I'm dividing by x cubed minus 4x. Okay, now is this fraction proper or improper? Proper, because the degree of the numerator is smaller than the degree of the denominator. Okay, so now what we're going to do is we are going to take this fraction right here, and we are going to split it into the fractions that add together to give me this 5x minus 2 over x cubed minus 4x. Okay, but at the very end, we can't forget this answer in front of it. So what I want us to do really quick right now is just next to this, let's put an equals 2x plus, and then when we are done, we will come back and fill the rest of that in for our answer. Okay, this is my answer box. Okay, we'll come back to that. All right. All right, so now what we have to do is we are going to rewrite my fraction part, because I'm going to split up my fraction into multiple fractions. So I've got 5x minus 2 equals x cubed minus 4x. Okay, the way that we split this up is we have to factor the denominator. Sometimes it'll be factored for you, sometimes it won't. In this case, it's not. So if I factor the denominator here, what could I take out of both of those? I could take an x out. And I've got 5x minus 2 on top. Now, what could I do further? Could I do something with the x squared minus 2 or minus 4? Yeah. What are we going to get on the bottom now for my factor? Yeah, x plus 2 and x minus 2. Okay, so we have factored the denominator here. So this is where we're starting now. I'm actually just going to rewrite it down below, so that way we don't get confused. Okay, now what we're going to do is we are going to split this up into the number of factors that I have in the denominator. Okay, I have how many factors here? I have 3. So I have 3 fractions. In one fraction, I'm going to have x as my denominator. The second fraction, I'll have x plus 2. And the last fraction, I'll have x minus 2. But I don't know what's going to be on the top. Okay, so we need to give it some variables. Instead of giving it x's and y's, because we've already got x's there, we're going to give it alphabetical letters starting at A, and then we'll use as many as we need. Okay, so I'm going to use A here, B for my second term, and C for my third term. Okay, so now what we need to do is we need to get rid of the denominator so that we can actually solve this. okay? So we call this, remember, multiplying by the least common denominator. At least common multiple, sorry. That's the word there. Which basically means I am going to always multiply by whatever my denominator is on the left-hand side, okay? So I'm going to multiply every single factor by x times x plus 2 times x minus 2. So I'm multiplying everything times x, x plus 2, x minus 2, each factor. If we were on Notability, you could copy paste this. So now I'm going to multiply these things out, okay? On the left-hand side here, when I multiply this together, what am I going to be left with? 5x. There we go. All of this stuff in the denominator is going to cross out with each other. So I've got just 5x minus 2 left over. Okay. In my next factor, what am I going to be able to cross out? The x's, right? So my x's go away. I'm left with a times x plus 2 times x minus 2. My b term, I've got x plus 2 on the bottom, so I'm going to cross that out with the x plus 2 on the top. And I'm left with b times x minus 2. And we are not going to be distributing these things. So you'll see why here in a second. We're just going to leave it as those factors. And then the last one here, what's going to cancel out? The x minus 2's, right? Those are going to cancel out. So cross those out. And I'm left with plus cx times x plus 2. I have 4 variables here, okay? So what we're gonna need to do is we need to think about some smart values that we can choose for x to plug in that's gonna get rid of some of those a, b's, and c terms, okay? So if I look, for example, at like this first term, letter a, is being multiplied with x plus 2 and x minus 2. What could I plug in for x that would make that term go away? Like, how would I make this factor of x plus 2 equal 0? Oh, negative 2. How would I make this factor equal 0? Positive 2. So you want to choose x values that make your factors go away, because then it's going to get rid of some of our terms for us. Okay? So this is the point where you get to kind of make some choices here. Smart choices, though. Okay, so we're going to start with let x equal 0. I'm going to let x equal, oh, no, sorry, we said 2. What am I writing? Let's let x equal 2. Okay? I'm going to plug in 2 for every single x value I see, and I'm going to keep my a's and my b's and my c's where they should be, okay? So if I plug in 2 on the left-hand side, 5 times 2 minus 2 gives me 8, right? Okay, on the right side, I've got a times 2 plus 2, which is 4, and then 2 minus 2, which is 0. But what actually happens there? If it's being multiplied by 0, it goes away, right? But I'm going to write it down so you see where I got it from. Okay, if I plug in 2 for the second one, I've got b times 2 times 2 minus 2, which is also 0. So this one also is going to go away. And now just by choosing a smart x value, we have c times 2 times 2 plus 2, which is 4. So now I only have the variable c. We got rid of everything else. The x's went away because we chose an x to plug in, and we chose a smart x to get rid of my a and my b term. So now I'm just left with 8 equals 8a. Yes, it should be c. Okay. So then we get that c equals, 1, right?
1, yes.
C equals 1. Okay, so our plan, what we're doing is we're taking these values at the end and we're going to plug them back in to where we have our variables here. So our final answer is going to have these 3 fractions plus that 2x from our original problem when we divided, but we have to figure out what those a, b's, and c's are. Okay, any questions on how I found c there? Okay, so now let's pick another value. What could I also choose for x that would maybe get rid of maybe the a or b term? -2. If I choose -2, it's going to get rid of my a term and what other term? My c term, okay? So I'm going to let x equal -2. If I plug in -2, I get -10 minus 2, that's -12. And that equals a times 0 times -4, which actually just goes away. Plus b times -2 times -4 and then I have c times -2 times 0. So that goes away as well. So now I'm just left with that b term and -12 on the other side. So I can go ahead and simplify this. That equals 8b, which means b would equal -3/2. Okay. So now I have my a, I have my b. I still don't know c. Okay? So, oh, I know c. I don't know a, sorry. I don't know a, but I know c and b, sorry. So we can choose any x value you want to plug in addition to my c and my b, and then I'll be able to solve for a, right? It doesn't matter what x value you choose. I could choose 10, I could choose 5, but maybe what's an easy value to plug in? 0. 0 or 1. 1 is also an easy number to plug in. So either one will get you the same answer in the end after you do the algebra. So I'm going to go ahead and choose 0. If I plug in x equals 0, I would end up with -2 on the left. And then I don't know my a value, so that's a times 2 and -2. Plus, do I know my b value? Yes, I do. -3/2 times, 0 times -2, right? So that actually goes away.
-3/2?
Yes, was it not? Yeah, it was -3/2. But when I plug in the 0, it goes away, right?
Yeah.
And then the last thing I've got is plus c. What's my c value? 1 times my x value, which is 0, and 2. That goes away as well. I forgot that this had an x term here too. So yeah, choosing 0 is a smart option. Okay? So now I can just go ahead and simplify this. On the left side, I got -2. On the right side, I've got -4a, which means that a is going to equal 1/2, right? So I got my a, I got my b, I got my c. Now we got to go back to that answer block and plug in our final answer. Okay, any questions on how I found a, b? So now that I have my a, b, and c, I'm going back up to my answer. And I am plugging in, when I see a in my fraction, I'm going to plug in a. When I see b, I'm going to plug in b. When I see c, I'm going to plug in c, okay? So a was 1/2, right? So I've got 1 over, I've got 1 over, my denominator for a was x. So I've got 1 over 2x. technically it's like 1/2 over x, right? But that's the same thing as 1 over 2x. Are we okay with that? 1 over 2x is the same as 1/2 divided by x. I got the x because that is from your partial fraction decomposition part right here. This is what I chose, right? Since there's 3 terms. So now the next one is b, so I'm going to write, for b, it's going to be -3/2, but my denominator is what? X plus 2. So I've got minus 3 over 2 times x plus 2, because my b value was -3/2. Okay, and then your last one here is we've got c, which was 1, so I've got plus 1 divided by, my fraction denominator for c was x minus 2, so I've got divided by x minus 2. Okay, so your whole answer, after we did the division, we first had the 2x as a whole remainder, right? So that went in evenly, so I'm leaving that in my final answer, and then I'm splitting up the fraction into 3 separate fractions that make up that one highlighted in yellow on the left. Okay, if I went and multiplied all of these by the same denominator here, I would end up getting back to my final answer that I was started with. Okay, questions on this one? Feeling okay about it? A little? Yes, Aspen. Okay, this is our second fraction. 2x over x minus 1 to the 3rd power. Okay, I first check, is this a proper fraction? Yes, it is. Okay, so we don't need to divide this out at all. We can go ahead and go to the second step automatically, okay? Which means I need to factor the denominator. Well, they did that for us already also. So that's nice. So now we can go ahead into the third step. We can separate our fractions out, okay? So this is done for us also. So I've got 2x divided by x minus 1 to the 3rd power. So how many denominators or how many fractions do you think we're going to have? 3. Nice job. So I've got 3 fractions here. However, when it is a multiple of itself, okay, this is kind of one of the special rules here, you are going to have the exponent of the denominator be the place in the fraction that it is. So like for the first one, it's just x minus 1. The second one is going to be x minus 1 squared, and the third one is going to be x minus 1 cubed. Okay, so whatever your exponent is, that is how many fractions you have, but then you split up your exponent into 1, 2, and 3 terms, okay? Now we ask ourselves, is each of these terms linear? Inside the parentheses, is x minus 1 linear? X minus 1 is linear, right? So on the top, on the numerator, we're just going to say A, B, and C again, okay? The last example we will do is going to have non-linear term, and then we do something different, okay? Yes. So I'm going to multiply every single factor by what? Yes, the least common multiple here. So x minus 1 to the 3rd power, that's what I'm going to multiply every single fraction by. So I've got times x minus 1 cubed times x minus 1 cubed times x minus 1 cubed and times x minus 1 cubed. Okay? So on the left-hand side here, I can just cross out my x minus 1's cubed, right? So I've got 2x left over on the left. Now, how many x minus 1's am I going to have in my first fraction there? I'm going to have 2, right? One of them cancels at the top to give me 2. So I have a times x minus 1 squared. How many cancel with b? 2 of them cancel, and I'm left with one of them, right? Oops. I'm at 1 on top there. So I've got plus b times x minus 1.
Why would it be like multiple?
And then c, how many are going to go away for c? All of them. So I've just got plus c here, okay? All right. So now we've got to figure out what my a, b's, and c's are. So what is a smart choice for x? 1. Okay, if I plug in 1 here, let's see what we get. I get, on the left side, 2 is equal to a times 0, right? Which goes away. Plus b times 0, which also goes away. And then I'm left with plus c. So that's pretty easy. C is equal to 2 there. Got one of them. Now, this was kind of that special case that I was talking about here. If I plug in another number, am I going to be able to get rid of b or a by itself? No. So what we're going to have to do is we are going to have to choose 2 numbers to plug in. It doesn't matter what 2 numbers we plug in, but if I plug in 2 numbers for x, then I will only have a's and b's left over, right? And if I have 2 equations with 2 unknowns, can we solve for one of those? Yes. So let's just pick, I always choose small numbers here. Let's choose x is 0. If x was 0 and I plug 0 in, I get 0 equals a times negative 1 squared plus b times negative 1. And I know what c is, right? C is now 2, so I can say plus 2. And let's just simplify that out here. If I simplify this, I get a minus b on the right-hand side. And then can we move that 2 over to the other side? Yeah, so minus 2. I've got now one equation with 2 variables. If I find another equation with 2 variables, I can solve it, right? So let's choose another value for x. What do we want x to be? Negative 1, okay. Let's choose negative 1. So if x equals negative 1, I plug that in. I get, on the left-hand side, I get negative 2. And then I get a times, this would be negative 1 minus 1, which is negative 2 squared, plus b times negative 1 minus 1, also negative 2 squared, and also plus 2, right? So I plugged in negative 1. My bad, this should just be negative 2. Thank you. Okay, so let's simplify this. I've got a times 4, so this is 4a, right? And this would be minus 2b. And then let's move that 2 over to the other side to give me a total of negative 4. Okay, so now I have these 2 equations, and these 2 equations have 2 unknowns, so we can solve it, right? Let's do that. I'm going to write them off to the side here, right next to each other. So I've got negative 2 equals a minus b. I've got negative 4 equals 4a minus 2b. Okay, so we can solve this however we want. Substitution, elimination, it doesn't matter. It's kind of set up so we could just solve it by, well, either one really works. What do you guys want to do, substitution or elimination? Elimination, okay. If I do elimination, that means I need to multiply this top by what? 2. Let's do negative 2, so that way when I add them, they go away, yeah? So negative 2 times negative 2, that will be positive 4. Negative 2 times a would give me negative 2a. And then negative 2 times negative b is positive 2b. Okay, so now I can add these together. I end up getting 0 is equal to 2a, and then the 0 again. So a equals 0. Now, there's a few things that you could do here. We could go back to the original equation up here. Oops. You could totally come back up here and plug in something for x, and then we know our A value and our C value, so then I could solve for my B value. Or, don't I have an equation with just A's and B's other places? Yeah, so let's just do that. So I know A is 0, so I can go back to one of these equations here. If I know A is 0, that means that B is equal to what? 2, because I would divide by that negative one, right? So I get B equals 2.
Where are you at?
So now all we have to do is we have to plug our answers back in to my partial fraction decomposition, which is up here with my fractions, okay? So my answer would be A is 0, so it'd be 0 divided by x minus 1, which really, do I need that? No, I can cross that out. So then I have plus B. B is 2. So I've got 2 on top divided by x minus 1 squared. And then for C is 2, so I've got plus 2 divided by x minus 1 cubed. So this right there is your final answer.
So it'd be like
Last one here. We've got to look at first, is it a proper fraction? Proper fraction. Do we all agree? Yes, because I have an x squared up top, and technically if I distributed this, it would be x to the 3rd power, right? So this is proper, so we don't need to do anything else. Second thing is we need to factor the denominator. Well, the denominator is already factored for us. So that's pretty nice. So we're good there. Okay. So now we can just go ahead and start the partial fraction decomposition. Okay. So I'm going to rewrite my fraction. And then I have to think, how many fractions am I going to have here? How many factors do I have in the denominator? I have 2 factors, so that means I have 2 fractions. I have x plus 1, and I have x squared plus 2. Okay. Now this x plus 1, is this x plus 1 a linear or nonlinear term? It is a linear term because it has a degree of 1 there. So I can go ahead and just put an a for the numerator of that partial fraction. Okay. My second fraction here, is x squared plus 2 a linear term? No. So this is not linear. So we would write on top bx plus c, or whatever you are in point of like your alphabet. It could be cx plus d, it could be ax plus b, depending on which fraction it is, okay? So it's not linear, which is why we have 2 things on top, bx plus c. Okay, now we can go ahead and multiply every single fraction by my denominator on the left-hand side here. So I'm multiplying everything by x plus 1 times x squared plus 2. Okay, I want to give you guys a second right now. Try and get rid of all of your fractions. Okay, multiply everything out correctly, but don't distribute anything. Go to the next step here. Okay, so take a minute and try it out. Help each other out if you are struggling with it, or ask me for help. So on the left side, all of this is going to go away. So we're left with x squared plus 3x minus 1. And then I've got the x plus 1's go away. So I have a times x squared plus 2. And I don't need to distribute. Okay, we're just going to leave it like that. And then for this one, a lot of you left your answer like this, because this will cancel out with that and have x plus 1. However, isn't that whole numerator being multiplied by x plus 1? Yes, so I need parentheses around that whole thing. Okay? So again, we're solving for a and b so that way we can plug in our a value and our b value and our c value back into our original fraction decomposition there. So what are some maybe good choices for x?
-2.
I like the idea, but if I square -2,
Yeah.
then I would get 4, so that wouldn't actually go away, right?
-1.
If I choose -1, which one's going to go away? This x plus 1, this whole term in blue is going to go away, right? So let's plug in -1. So if x equals -1, on the left side, I would get 1 minus 3 minus 1, right? So that gives me just -3. On the right side, I have a times, if I plug in -1 here, -1 squared equals 1 plus 2 would be 3. And then I've got plus bx plus c in parentheses. Oh, my x is -1 technically here. But it would be multiplied by 0, so that goes away completely. And I'm just left with 3a is equal to -3. Which means that a equals 1. Totally would be. It would be -1. Thank you.
How does that whole,
So I know my a value. I still need to find my b and my c value. What is maybe another option we could choose to plug in to get rid of either b or c? 0. Because if you look at with the b, I have that times x, right? So that's going to get rid of my b value. So let's go ahead and plug in x equals 0. I would get on the left side -1 is equal to, I know what a is now, so I'm going to plug in my a value, which is -1. And when I plug in 0, I get 0 squared plus 2, which is 2, plus my bx plus c, so that would be plus b times 0 plus c, and then that is times 1. So does the whole blue term cancel out, or does just the b term cancel out? Just the b goes away, okay? So I'm left with that -1 equals -2 plus 1 times c, which is just c. So this would give me c is equal to +1. Okay, so I know my a, I know my c, I need to find b. Okay, at this point, it doesn't matter what I plug in because I have everything else except for b, right? So choose any x value. What's maybe an easy x value that we could plug in? 1. So now I can choose any x value. That doesn't matter what x value. Let's choose 1 is what we decided, right? Bless you. So if I choose x equals 1, and I plug that in on the left, I get 1 squared plus 3 minus 1 is 3. And then we know a is -1, so -1 times -1 squared, +1, plus 2 times 3, plus b, I still don't know, so I've got b times x, which is 1, so I can just leave it as b, plus c times 1 plus 1, which is 2. Oh, you're right, c is 1, thank you. Okay, so now we just got to solve this for b. So I'm going to go ahead and add this -3 over to the other side. So I get that 6 is equal to, I'm going to rewrite it like this, 2 times b plus 1. You can do one of two things. We could distribute or we could divide by 2. I'm just going to go ahead and divide by 2. So I've got 3 equals b plus 1, which means that b equals 2.
Confused how you got the 3 is.
Okay, so then you just got to write your final answer out. So I'm going to go back up here, just kind of off to the side. And my final answer, I'm plugging in my A's and B's and C's. So I've got A is -1. So I got -1 divided by x plus 1. And then plus B, which is 2, so 2x, plus C, which is 1, all divided by x squared plus 2. I don't know why it wrote so much larger on that second fraction there. Okay? And if you wanted to, on the other side, have the x, like the original problem of x squared plus 3x minus 1 over that fraction of x plus 1, x squared plus 2, you could. But this right here is your final answer. If you would combine those together, get common denominator, you would end up getting the original problem that we started with. Okay?